Good morning, one and all. So, in continuation to the topic, we are going to discuss about the neural control and coordination. In this topic, we are going to talk about the level 1 questions of the neural control and coordination. So in the first question in this level 1, so in human, autonomic nervous system is composed of, generally we see the system, peripheral nervous system and autonomic nervous system is present in our body. Autonomic means which functions on its own, and we know that autonomic nervous system is composed of two components. One is the somatic nerve, one is the sympathetic nervous system, and one more is the parasympathetic nervous system. Sympathetic nervous. So this somatic neural system is this sympathetic nervous system will increase a certain will show the sympathetic pathway, as well as parasympathetic will control the sympathetic pathway, and this autonomic nervous system will act on the body to either if fear is increased, parasympathetic nervous system will decrease the fear, and if there is any other components like the sympathetic nervous system and parasympathetic nervous system are the components of the autonomic nervous system. So here we can see that the sympathetic nervous system and parasympathetic nervous system will will be composed of autonomic nervous system, and this is generally used for the body maintenance of activities. Now coming on to the next question, intercellular communication in multicellular organisms occurs through. So the in our body already we have discussed that the nervous system and endocrine system are called integrative system, because they will control all the functions of the human body, either internal or external to the body, and these are also the intercellular communicators in our body. So both nervous system and can contribute to the intercellular communication in the human or multicellular organisms. So here D option is the right option. Integrative systems in the body, already we have discussed that the nervous endocrine system, the the endocrine system and nervous system are collectively called as integrative system as we have discussed earlier itself, to maintain the normal body functionality. So integrative system in the body is both A and B, that is D option. D option. Next, skeletal muscles are voluntary muscles, and they are controlled by nerves present in the somatic parts of the body. So sympathetic is autonomic nervous system, parasympathetic autonomic nervous system, and autonomic nervous system, the above two are nervous system is peripheral nervous system. So the skeletal muscles are controlled by somatic nerves. Somatic nerves. By which nervous system the blood is supplied into visceral organs? Sympathetic nervous system voluntary, sympathetic nervous system involuntary, parasympathetic nervous system. So you know that autonomic nervous system itself is a is called as a autonomic nervous system itself, involuntary in function. So here answer D, option D is the right answer. Next, when you talk about a structure of which of the following statement is correct about node of Ranavir of now. So node of Ranavir is a space present between the gap present between the two myelin sheath coverings. So here generally nodes of Ranavir is found uh, between the discontinuous myelin sheath. Already we know that neural lemma is discontinuous. My neural lemma that is not discontinuous. Myelin sheath of the neural lemma. The neural lemma is discontinuous. Both neural lemma and myelin sheath are discontinuous, covered by myelin sheath. Generally, nodes of Ranvier is a myelin sheath discontinuation and forms a node. So answer can be the myelin sheath in the nerve cell is a discontinuous one. Option B is a right one. And next question. So the type of neurons present in the dorsal root ganglia of spinal nerve is unipolar, pseudo-unipolar, bipolar, multipolar. So whatever most of the neurons we see in our human body is multipolar. Unipolar can be seen in the uh, embryonic stages, and pseudo-unipolar where it can be also pseudo-unipolar. These pseudo-unipolar are present in the dorsal root ganglia, and bipolar are present in the retina, multipolar in most of the body. So the type of neuron dorsal root ganglia of spinal nerves is already we have discussed that pseudo-unipolar is present in the dorsal root ganglia. So answer for this can be pseudo-unipolar, means in this the cyton will be like this. Answer is B is the right option. Next, which part of the neuron is highly branched and efferent? Axon, dendrite, cyton, both A and B. Which part of the neuron is highly branched and efferent? So when you see onto the when you see onto a neuron structure, so this is called cyton or pericardia, and here at these are called as dendrites, and in the middle nucleus will be present. Nucleus is supported by a specific type of cells called as neuroglial cells. And this is axon. At the terminal of the axon you can see the now terminals. So based on these, okay, which part on is already you know that dendrite is mostly branched. So B option B is the answer. Next, motor end plate junction is present between. So the muscle attachment to the nerve terminals is called as motor end plate. So here the neuron and muscles will give you the answer motor end plate. So motor end plate is a combination of neuron and muscle cells. So option A is the answer for this question. Answer is motor end plate junction is present between the neuron and the muscle. Neuron and the muscle. So 10th question. So which of the following part of neuron is covered by a fatty sheath? So myelin sheath, already you know that myelin fatty sheath because it is made up of fat strand cells, and strand cells from the myelin sheath, and it is covering the axon, and it is um, it is discontinuous on the axon in the multipolar point of view. And the part of the so here we can go only with the answer. Dendrite, already you know that dendrite is a branch structure. Cyton means cell body or pericardia. The cyton is also called as pericardia or cell body of the cell. So here the answer for this is axon. Axon is the answer for axon is covered by myelin sheath. Answer A. Answer A. Next, presynaptic presynaptic membrane is a part of dendron, axon, hillock, telodendria, soma. The other name of the cell body or pericardia or cyton or soma is one and the same. Axon hillock means the space present between the axon, and dendron means the dendrite is called dendron. Telodendria means now terminal. So here presynaptic membrane is part of a telodendria, that is C option, that is nothing but the at the now terminal. This is now terminal. Now terminal. Next, bipolar neurons are found in, already in the recent questions we have discussed that bipolar neurons are found in the retina of the eye. Retina of the eye. Option is 12th question. Option is A. Next. Coming on to the 13th question, you are seeing the diagrammatic representation of a now of a now neuron. So in this is a multipolar neuron. This is a multipolar neuron, and it is unipolar in aging cells. So correct option. It is unipolar. It is multipolar in. So option A is wrong. Option A is wrong. It is of only two types, dendritic and axonic. Cyton is also present, so this is also wrong. It is unipolar in embryonic. Already we know that it is unipolar in embryonic stage, and it possesses multiple nuclei. It possesses only one nucleus, so fourth option is also wrong. So option C is the right answer for the 13th question. Next, coming on to the 14th question, select the incorrect statement. Here they are asking about the incorrect statement. The Nissl granules probably synthesize fats for the cell. Aging neuron contain a pigment lipofuscin, right? Nissl granules are irregular masses of rough endoplasmic reticulum, and none of these. So here the Nissl granules probably synthesize fats. Nissl granules are the function of Nissl granules is nurturing or nutrition, and it is not synthesizing. It is myelin sheath is synthesized by Schwann cells or myelin membrane. So Nissl granule function is nutrition. So here A option is the right option, and incorrect statement is the A statement. Next. Next, 15th question. Select the correct statement. Correct statement. Select the correct statement. So here we are seeing that unipolar neurons occur in nidarians. Pseudo-unipolar neurons found in the dorsal root ganglia of spinal nerve. Non-polar neurons found in the embryonic stages. Non non mm, non-polar nucleons found in the embryonic stages, and all of these. So here they are asking about to find out the correct statement. Unipolar neurons are found occurs in the embryonic stages. So it is wrong. Option is wrong. Pseudo unipolar nuclear root of spinal. So, pseudo-unipolar nucleons found in the dorsal root ganglia of spinal nerve. These are found in the nidarians. These are found in nidarians. So, this B statement is wrong, and non-polar neurons found in the non-polar or unipolar is found in the. So here option B is the right answer. Option B is right answer. Next. Read the passage given and select the correct option to fill the blanks. So we'll try to fill the blanks now. Neurons are the structure and functional units of neural tissue and are the longest cells in the body. Fully formed neurons remain in dash of the cell cycle throughout the life. They remain in the non-dividing phase or G0 phase, or they remain in the interphase of the cell cycle throughout the life. Neurons with flash-shaped cytons are called as Purkinje cells and are located in the cerebellum part of the brain. So here the neurons are the structure and function unit of neural tissue and are the longest cells in the body. Fully formed neurons remain in a non-dividing phase or interphase, means which are unable to divide. Only they will divide once and they will go into the interphase. So when you talk the flask shaped we have come across in the topic discussion that they are called as Purkinje cells, and generally these are located in the cerebellum. So by checking these options, the most appropriate option we are seeing is the B option. So B is the answer for that 16th one. B is the answer. Next. Four healthy people in their 20s got involved in injuries resulting in a damage of and death of few cells follow in the in their 20s got involved in the injuries resulting in the damage and death of few cells of the following. Which of the cells are least likely to be replaced with neurons. Already, as we have discussed, that bone cells can be reformed. Malfeasance layer of the skin is also can be grafted and also can be reformed. Liver cells has most regenerative capacity, but neuron cells, in the case of polio patients, we have discussed that motor neurons are affected and they cannot be regenerated once again. So here, whenever the neurons are destroyed, in any case, neurons does not will lose the capacity to regenerate. So here, healthy persons, when they are damaged, with the neuron cells are damaged in a person, they cannot be regenerated once again in their lifespan. So they has to suffer with that only. Option D is the answer for this question. Next, coming on to the next question. In In a modulated fiber, the conduction of impulse is faster due to the presence of pericytes, endoneurium and epineurium, myelin sheath and rods of Ranvier nasal granules. In a modulated nerve fiber, the conduction of impulse is faster because of the covering. When electricity is passed through a unwide turnouts and wide turnouts, you can see that wide turnouts are meant for are covered with a plastic coating, and they will also transmit the information very fast. So here also, in the same way, the modulated neuron or myelin sheath containing neuron and the nodes of Ranvier, generally the impulse conduction is fast when compared to the unmyelinated neurons. So option here is C option. Myelin sheath and nodes of Ranvier, the impulse conduction is generally fast. Next, next one. Now fibers get depolarized when it acquires. Depolarization. Anytime, please remember the term that depolarization. If the term depolarization is used, it is negative. So here negative charge, sorry, depolarization means coming back to the, I mean, there will be shift in ions. So now fibers get depolarized. Charges, positive charges on the inner side will be shifted. The positive charge outside, negative, more negative charge inside, more positive charge, that will be generally shifted. So your answer for this question is A. Now fiber gets depolarized when it acquires a positive charge from inside. Now fibers get depolarized when it acquires a positive charge on the inner side, and that will be depolarized, and outside will be more, I mean, outside it acquires the negative charge. So based on the movement of ions. Next, coming on to the next question. So 28th question. A short period during which a nerve is unable to the nerve impulse is called synaptic delay. Refractory period means refractory period is also Refractory period is also called as a adjustment period or stabilizing period. So there will be uh, no impulse conduction during the refractory period, that is between the depolarization and and repolarization depolarization and repolarization. Next, here you are seeing a statement with four important points taken into consideration. Uh, Four important points into consideration. So here, read the given statements and select the correct option. Please identify that you need to select a correct option. Here, continuity between the presynaptic and postsynaptic neuron is provided by gap junctions in chemical synapses, and release of calcium ions from the presynaptic knob stimulates the release of neurotransmitter into synaptic cleft. More energy is required for impulse conduction. More energy is required for impulse conduction through myelinated neurons due to salutary conduction. After after transmission of impulse, neurotransmitter is hydrolyzed by the enzyme present at the synapse. When we are seeing, you need to select the which options are only correct options. So here the continuity between the pre presynaptic and postsynaptic neurons is provided by gap junctions in the chemical synapses. Release of calcium ions from the presynaptic knob stimulates the release of neurotransmitter into the synaptic cleft. More energy is required for impulse conduction through myelinated neuron conduction. After transmission of impulse, the neurotransmitter is hydrolyzed by the enzyme present at the synapse. So it will not be the neurotransmitter can will not be hydrolyzed. So here, uh, so first one, two, three options, that is first option is a wrong option. The continuity between the presynaptic is provided by gap junctions in the chemical synapses. It may be or mechanical synapses. Release of calcium ions. Calcium ions is especially involved in the muscle contraction and muscle relaxation. More energy is required for impulse conduction through myelinated, very less amount of 0.055, and after neurotransmission of impulse, neurotransmitter is hydrolyzed by an enzyme present at the synapse left called as Gaba is present. So here here the 1 2 3 option 1 2 3 are incorrect, but 4 is correct. So D option is the right option for the statement. Next, which one of the following is an inhibitory neurotransmitter? Which one of the following the inhibitory neurotransmitter GABA? So the name of the GABA is a powerful neurotransmitter, that is the answer, but that is gamma amino butyric acid, that is MCNS. So it is a very powerful neuroinhibitor, and adrenaline is produced by the adrenal gland, and it is also going to act, with the help of it is the other name of the adrenaline is called as epinephrine, and acetylcholine is a powerful neurotransmitter. So epinephrine is a neurotransmitter powerful neurotransmitter. So your GABA particle, that is a inhibitor, powerful inhibitor. And next, coming on to the next question here. Suppose the terminal ends of an axon are in contact with the dendrites of four neurons. The nerve impulse of the axon will travel in all the four directions, get distributed in all the four neurons, resulting in a weak impulse, travel only in one neuron which is closest contact with the same intensity, travel in none of the neurons because the impulse travels from dendrites of one neuron to the axon of the. So here the nerve terminal ends of a axon contact with the dendrites of four adjacent neurons. The nerve impulse of the axon will travel in all the directions. So travel in all the directions, travel in all the four directions, travel in the all the four directions. Option A. Next. Next, transmission of across a synapse is accomplished by release of phosphorus ion only, movement of Na plus and K plus, and release of neurotransmitters, movement of water level. So here once again we'll try to understand the question. Transmission of nerve impulse across a synapse accomplished by the so release, that is generally based on the release of neurotransmitters, that is C option. C option. So based on the release of neurotransmitters, the movement takes place. Next question. The slowest neurons transmits at the speed of about and faster ones at the over speed of. So the scientist has discovered that the slowest neuron will be transmitting a impulse for zero point 0.5 meters per second, that is the slowest one. And the highest, now they are saying that it is 125 meters, but approximately above 100 meters per second is the fastest neuron transmission method. Next, coming on to the next one, select the correct sequence of conduction of nerve impulse. Select the correct sequence of transmission of nerve impulse. So here we need to go with the correct method. High concentration of K plus ion in exoplasm, threshold stimulus, influx of Na plus ions, action potential generation, efflux of K plus ions, high concentration of Na plus cytoplasm, depolarization, threshold stimulus, repolarization, action potential generation, high concentration of K plus ions in the fluid outside axon, threshold stimulus, influx of K plus, action potential, efflux of Na plus, resting potential, depolarization, threshold stimulus, efflux of Na plus, action potential, and repolarization. So here the correct sequence of conduct of, so when there is a high concentration of K plus ions in the exoplasm, then there is a threshold, means highest limit, highest stimulus is raised, then the movement of Na plus ions inside and the movement of Cl minus ions outside, then an action potential is generated, then movement of K plus ions takes place. As a result, the nerve transmission will take place nerve from one position to the other position as per the movement of action potential from A to B, B to C. At the same time, C to B, B to A in the sodium and potassium pump channels. Next, coming on to the next question. Next, unidirectional transmission of nerve impulse through nerve fiber is due to the fact that nerve fiber is insulated by a medullary sheath. Sodium pump starts operating it only at the cyton and then continues into the nerve fiber. Neurotransmitters are released by the dendrites and not by axon endings. Neurotransmitters are released by the axon endings by not by dendrites. So neurotransmitters know that they are produced at the nerve terminal. So here option D is the right answer. D is the right answer. D option. Next, resting membrane potential is maintained by hormones, neurotransmitters, ion pumps and angels. Already we have discussed that sodium and potassium pumps will maintain in the resting potential. So answer is C, ionic pumps. Next, in saltatory conduction, in saltatory conduction, time is both are conserved and neither time nor energy is conserved. So your saltatory conduction of nerve impulse require less amount of energy for action because only the nodes of runaway are depolarized and fewer ions are required to be pumped back into the position by the energy requiring active transport mechanism. So because of this saltatory conduction, that is fast conduction, the ion requirement is less and the energy conservation is also. So here option both the energy and time are both the energy both the energy and time are conserved in the salutary conduction of impulse. Next, last and final question for this particular day. Action of which neurotransmitter is inactivated by a enzyme monoamino oxidase? Acetylcholine is a powerful neurotransmitter. Norepinephrine is uh, produced again is the adrenaline, that is noradrenaline. Noradrenaline or norepinephrine is same. Gaba is a gamma aminobutyric acid which is a powerful neuroinhibitor. Serotonin is a component produced by the basophils in the case of the allergic reactions, but inactivated, which powerful neurotransmitter is inactivated by the enzyme? So here the during the excessive allergic conditions, so a monoamino oxidase, that is generally which this is a keto-kilo-amine neurotransmitter broken down into the in the uh, extracellular fluid of the axon terminal by enzymes monoamino oxidase drugs known as MAO. This is generally going to inhibit the and increase the amount of norepinephrine and dopamine in the synapse by slowing down their metabolic degradation. They are used to in the treatment of that is mood disorders or psychological disorders or suffering from the anxiety or depression. So here monoamino oxidase is a antidepressant used to reduce the power of norepinephrine, that is monoamino oxidase, which is used in the depression treatment. depression. So answer B option.